Oh, forgot to record. Okay, so let's go ahead and graph the function, much like we have here. Now, where do we find, did I show you guys where to find absolute value on there? Okay, well, let me show you. Yeah, you can go, there's a couple ways you can do it conveniently. I think there's actually, let's see, there might even be a shortcut. If I go to window, oh, you got, I don't know that shortcut. I think if you go function, okay, there's a really easy way. There's one way. I'll give you a bunch of ways.
Thank you.
So does everybody see this right here? This, I just hit alpha F2. So once again, let me clear that and do it again. So alpha F2 gives me absolute value, right? ABS. Now notice in this window it does something kind of cool. Not only does it show you the name of the function, to the right it shows you how it's going to be rendered on the screen. So you're actually going to see absolute value bars.
Redo the whole thing.
Yeah, I just went alpha F2. When I hit alpha and I hit any button, F1 through F4, notice that it gives me it tells me what all those buttons are. Alpha F1 is my fraction template. Alpha F2 is my function template, so it gives me a bunch of commonly used functions. Alpha F3 would be matrix stuff, which we're going to talk about shortly. And then alpha F4 would be my Y variable template.
Do we have to have the update to have
You do. You have to have the update to see this stuff, yeah.
Why do I even try?
Okay. So now, if you don't have it though, okay, listen please, listen. I know today's a big day, but I want to get through this and give you a chance to work a little bit. Okay, so if you don't have that, that's the easiest way to get to it. There's some other really simple ways that don't require the new setup. So you could also just go, if you hit the math menu and you shift right to number, it's the first option. So you can go math, number, and then absolute value. Or the other really convenient way to do it, there's just an embarrassment of riches here. The other way you can do it is you could just go second catalog, and it's the first alphabetically absolute value. It's all just a big alphabetical list, but it's the first one. Okay. So then all we have to do, did you have another one, Elton?
Hold on. There's
Okay.
an alphabetical list in here?
Yeah, of the catalog, of all the functions. Okay, so then if we go to y equals, oops, let's just go to y equals and let's graph this thing. Okay, so then we're going to do 2 times, and you don't even have to put a times in there. We're just going to do 2 absolute values, so take your pick of whichever way you want to do it. I'm going to go alpha F2, is that what it was?
Yeah.
Alpha F2, enter. Absolute value of x minus 2. Scoot to the right to get out of the absolute value bars and subtract 1. And then I'll just go, everybody with me?
Yeah.
Okay, zoom 6. Remember, that resets the screen. And so there's my absolute value function. Okay, everybody see that? Right? Okay, now if we want to figure out where that equals 2, then I'm just going to go back to y equals, and I'm going to define a second function, y equals 2, and just graph those at the same time. Now that's pretty good. I can graphically see where the intersections are, right? Let me make this so you can see that bigger now. How about if I do like that? Okay. What's that?
Upside down.
Okay, now why would yours be upside down? Let's answer this. What would we have to do? What do you have to do to flip an absolute value function so it's upside down? You got to reflect it. Okay, good. So you must have a negative 2 out front.
No.
You sure?
Yeah.
Oh, this is a mystery. That mystery. That's a negative sign, not a minus sign. That's a minus. So you did, it ended up actually being negative. So that's. There you go. All right, here we go. Okay, so the next step. Next step, how do we find the intersections? Really simple. Whenever we want to do something on the calculator that involves a graph, right? We want to use the graph to extract some information. Remember, that's where we go, second calc. Which one of those options do we probably want here? Intersect, good. So we want 5. And then here's where it's going to prompt us for some information. It wants to know, is y1 the blue curve? And notice that it actually puts the cursor on that curve. It wants to know, is this your first curve that you're intersecting? Well, we've only got 2, so yes, it is. I hit enter. Is the red one the second one? Yes, it is. Now it wants a guess. Well, I want the guess to be close. Being as there are 2 intersections, I want to go close to the one that I'm interested in. So let's find the left one. I'll move the cursor over real close to the left intersection and hit enter. And it tells me that the intersection is at x equals 1/2, y equals 2. Okay, let me do that again. Let me do that again. So we're going back to graph, right? There's the graph. Now we're going to go second calc, gets us to this screen, the calculate screen. And that when we say calculate, we mean we're going to use the graph to calculate something. Okay? So let's do number 5. And then it's going to do several things. It wants to know which 2 curves are you intersecting, right? Well, one of them is y1. If I go left or right on this thing, notice that I'm just shifting along the blue curve. So it gives me a visual. It asks, is y1 equals to absolute value x minus 2 minus 1, the first curve, right? Notice the question mark at the bottom. That's called a prompt. It needs some information. It wants to know which 2 to intersect. So we confirm by hitting enter that that's one of the ones that we want to intersect. The second one is y2 equals 2. It's red, and notice it puts the cursor on that line. So to confirm that that's the second one, we hit enter. Now it wants a guess, right? And once again, the reason for the guess is that there are multiple intersections. We got to know which one are we looking for. Well, let's look for the left one. So if I move over close to the left one and hit enter, we get x equals 0.5, y equals 2. Right? Okay? So one of our solutions then, if we go back to this original problem, one of the solutions is what? 0.5. 0.5. One of them is x equals 1/2, right? So we're halfway there. X equals 1/2, or we'll go over and find the other one with the same process.
It can't be at the same time.
No, you can only do one at a time. Okay, so everybody try this. Try it on your own. Try to find the second one. I'll go through it up here silently, but you try to find it on your own.
You can't have so. Never mind.
Never.
That's not what I meant. Wait.
Find the other solution. Yeah, you bet.
What? Got it. Seriously?
What'd you get? 3.5?
Yeah.
Okay. Yeah. Never mind the thing.
Wait, how do you get it to tell you what it is again? Press enter, right?
You got to go through second calc. Say it
Do
again.
it again.
Okay, here, I'll tell you what. We got to fix something here. I would appreciate it if you guys, because we got so much communication going on, I would really like it if you would raise your hand, and I will call on you, okay? And then that way we can control this so it doesn't get so confusing. Okay, so to find this graph, there we are, right? So to find the other one, we go second calc, gets us to this screen, right? 5 is intersect. And then we have to tell it, is this the first curve? Yes. Is the red one the second curve? Yes. And then make your guess. Well, I've already traced over there, right? So I want to put the cursor next to the second intersection and hit enter. And I get 3.5 and 2. I'm going to use my ordered pair, right? So the other solution is 3.5. Okay?
Oh, so why isn't a solution? Oh, it's gonna say the same, never mind. Yikes.
3.5, so what is that, 7/2? Is a fraction, okay, make sense? So those are my two intersections. So you see how we can do this, not just with absolute value functions, we can do this with any function. If we graph the function and we want to find where the function, essentially the left side of the equation, is equal to a number on the right side, a constant on the right side, then we'll just graph that vertical line and look for the intersections. Okay, that's a really handy way to quickly find a solution. Okay, based on this graph, you kind of get the idea that when you solve an absolute value equation, it's not unusual to get two answers, right? Does that make sense? And there's another way we'll look at that in a second. Is it possible that you could get no solutions? What could I change up here in my original equation to come up with an equation that has no solutions?
Change the y value to like -7 or something.
Okay, I could change the y value on the right side to something where the vertical line would be below, everybody see that would be below the graph. What if I went down to -2, for example, right?
Well,
Well, I'm supposed to be negative, what happened there? Oh, well, there we go. I tried to be kidding.
oh, Mr. Whiteout.
I know. It's- Okay, so if I made that -2, now we can see that I'm not gonna get any solutions,
Yes.
right? What if is there a way I could get a single solution instead of 2 or 0? What do you think? Yeah, what if x equals -1? So then, in other words, what if the y value of the function was the same as the y coordinate of the vertex, right? That make sense? Okay. So in general then, when we're solving these kinds of equations, let's keep in mind that absolute value of x is really just giving us the distance from x to 0 on a number line, right? Everybody agrees? So I could make that more complicated. If I had something like, let's say, the absolute value of x plus 4, really, if I want to know what the solutions of that are, I know that whatever's behind my hand, the value of that represents its distance from 0, right? Does that make sense? So the absolute value of hand is either equal to, in this case, if that's equal to 0, what if the absolute value was behind my hand was 5, right? Then the number in there could actually end up being equal to 5 or -5. Does that make sense? Okay, because I'm really just representing a distance. It doesn't just have to be an x, right? So what are the possible values of x? 5 or -5, right? What if we had instead, this will make it a little clearer, I think, what if I had something like x minus 2, absolute value of x minus 2 equals 5? Well, if the absolute value of hand equals 5, hand could be 5 or -5, right? So then whatever's inside the absolute value bars, we call that an argument in math, the argument of the absolute value function. We would set equal to 5 or -5 and solve, right? So our strategy ends up being pretty simple when we're solving an absolute value function. All we've ever got to do is just, once we get the absolute value part of the equation isolated, so it's equal to some number, we're just going to trade the absolute value equation for two non-absolute value equations, right? So once we get it to look like this, the absolute value of, let's call it ax plus b equals c, where c is some positive number, then we're going to trade that for either ax plus b equals positive c or it equals negative c. Those are both going to produce solutions, right? Make sense? Okay, so we could have done our original problem then. Let's go back to our original problem we had. It was 2 times absolute value x minus 2 minus 1 equals 2, right? Okay, how are we going to do that? What are the steps when we're going to solve this absolute value equation? What are the steps we're going to do? Right? We want to make it look like that, right? gotta look like that. So what's that involve? What do you think, Sam? So we're gonna add one, and then what next? Then divide by 2, right? Okay, and a way of thinking about that, if you want to articulate a strategy, the strategy is you're just going to isolate the absolute value bars, aren't you? You're going to get them by themselves on one side of the equation. So we add 1, divide by 2, and we did it. Right now we've got the absolute value of x minus 2 equals 3/2, right? Okay, here's where we've got to rewrite this. And this is something that's you're going to see from now on. We deal with absolute value functions in my calculus class quite a bit, for example. The strategy is always kind of the same. Absolute values are inconvenient. You can't do normal algebra with absolute value bars because they don't act normally, right? They're a piecewise function. They have different behaviors in different places. And so what we always want to do, all the way up through multivariable calculus in college, when you're dealing with a situation involving absolute value functions, you always want to just rewrite the absolute value in a way where it doesn't use absolute value bars. We're going to trade the absolute value equation in this case for 2 regular equations that we know how to deal with. Okay? So what's that split going to be then? One equation is going to be what? X minus 2 equals 3/2, right? Because what's inside the absolute value bars might just be positive. What's the other one, though? Okay, good. X minus 2 could also actually equal negative 3/2, and the absolute value makes it positive, right? We're going to trade for those 2 equations, and now it's easy. Now all we have to do is just solve those 2 regular equations individually, okay? So we add 2 to both sides, and we get x equals 2 plus 3/2 is, what, 7/2? And over here, if we add 2 to both sides, negative 3/2 plus 4/2 plus 2 equals 1/2. Okay, make sense? Okay. What would happen, just looking ahead here, minor issue, what would happen if I did some problem and when I ended up isolating my absolute value bar, so I did a bunch of algebra, and I got the absolute value bars by themselves, and let's say I had something like x plus 7/3 equals negative 1. Do I have to go any further? How come? What's wrong with this picture? How can we see right away the answer is no solution? Because it's negative, yeah. It's impossible. The absolute value of hand, what's the job of absolute value? It's going to make whatever we put into it, the value of that positive, right? And so if the answer is negative, it's impossible to do, right? The output of an absolute value function will always be positive. So therefore we can see right away, because that's negative, no solution. Make sense? Okay. I think that's good.